We've got a really wild one for you today.
Yeah, picture teenagers bombarding AI chatbots with dark, twisted questions. It sounds like typical internet chaos. But these kids aren't actually teenagers. They're highly paid operatives working directly for Meta.
Welcome to the deep dive. We're examining the hidden machinery of the AI boom today.
It's a complex and honestly invisible landscape out there.
Right. We're going to start with the murky ethics of corporate espionage. Then we transition into the friction of human adaptation. How are everyday people colliding with these massive systems?
And then we finish up with a profound hardware leap from NVIDIA.
Exactly. No hype here today, just an intellectual exploration of a wild frontier. Let's get right into it.
So the bleeding edge of AI competition is getting really complicated. Companies are fighting dirty to test safety limits.
And that brings us to this covert operation orchestrated by Meta. They ran this through a contractor called Covalin.
Yeah. These paid workers use throwaway accounts online. They actively pretended to be under 18.
Their core mission was secretly testing rival models' guardrails. We're talking about systems like ChatGPT and Google's Gemini.
Right, and the prompts they used were not innocent at all. They pushed these models on incredibly severe, dark topics.
Like self-harm and eating disorders.
They also probed for information on illegal substances and violence.
Across tens of thousands of different queries.
They wanted to see exactly where the competitor models broke. But the human cost of this operation is deeply troubling. Workers felt entirely gobsmacked and unsettled by the generated text.
I mean, reading generated violence all day is mentally devastating work.
Absolutely. It echoes past controversies over Meta's human content moderators. People forget that AI safety relies on hidden human trauma. These workers are absorbing the darkest corners of synthetic media.
2-sec silence. It reminds me of a very specific scenario. It's like sending undercover agents into a rival bank. You want them to break into the competitor's vault. You tell yourself you're just testing their security systems. But in the process, you end up severely traumatizing your own agents.
That is a perfect way to frame it. Now, Meta defends this as an industry standard practice today. They argue they need to gather critical benchmarking data sets. They're engaging in a process known as red teaming.
Let's define that term for clarity. Red teaming is testing a system's defenses by playing the attacker.
Exactly. It comes from military simulations and cybersecurity. You attack your own systems to find the weak spots. But here, Meta is red teaming their competitors' models.
Which is why AI ethics experts are pushing back very hard.
Yeah, they're calling this a dangerous governance gray zone.
Wait, let me play devil's advocate for a second. Shouldn't we want companies testing these limits? If ChatGPT has a flaw, someone needs to find it.
That's the core of Meta's defense right now.
Yeah.
But the intent and transparency are what actually matter here. This was completely hidden from their direct competitors.
So the safety findings were never shared with the public.
Right. If you find a flaw, you should report it. Instead, they hoarded the data for a competitive advantage. It looks less like safety and more like corporate sabotage. The line between necessary testing and anti-competitive behavior is blurring.
It raises a very important question about corporate motives. Is safety just becoming a convenient excuse for corporate espionage?
Yes, unfortunately. It provides a moral shield for aggressive, anti-competitive data mining.
Safety is just a mask for stealing competitive data. Beep beep. That brings us to our next major theme today. We're moving from Meta's contractors to the broader workforce. Society is actively colliding with these AI models.
We're witnessing the phase-out of hidden human labor. A huge milestone is happening in that space very soon. Amazon is officially closing Mechanical Turk to new customers.
That happens on July 30th, 2026. Mechanical Turk has been around for a long time. It was a platform for tiny, outsourced human tasks. These tasks were often disguised as seamless machine automation.
Yeah, it was the original invisible labor force. Companies used it to label data or identify images. Existing users can stay, but no new features are coming.
This marks the true end of a very specific era. Machines can finally do those microtasks cheaper than humans.
But as that labor era ends, a new divide begins. We're seeing a massive educational wealth gap opening up.
Traditional schooling still works for many everyday kids, but high-earner families are rapidly pivoting their educational strategies. They're prioritizing entirely different skills for their children.
They see the writing on the wall with AI. Memorizing facts is no longer a valuable economic skill, so they focus heavily on AI literacy and early business fundamentals.
They're also prioritizing advanced public speaking and communication.
Right. They want these life skills secured before high school.
It makes complete sense from a strategic standpoint. If the AI can write the code or do the math, what's left? You need the human ability to direct the machine. You need the charisma to persuade other human beings.
Exactly. We also see a corporate divide happening right now. Look at Samsung's recent AI boom and their financial success. It resulted in a staggering $26 billion bonus deal.
That's an astronomical amount of money.
Yes. But the distribution of that money is the real story. Chip workers were promised payouts of up to $400K, but non-chip teams received incredibly tiny, insignificant payouts.
I can see how that destroys morale instantly.
It's severely fracturing the company's internal culture today. You have hardware engineers buying houses with cash.
Yeah.
Meanwhile, software or marketing teams feel entirely left behind. They're working at the same company but living totally different realities.
This friction pushes humans to get highly creative, though. Let's talk about human ingenuity and clever AI hacks. Developers are finding fascinating ways to bypass economic limits. There's a wildly creative Fable 5 large context hack.
Oh, this one is just so incredibly brilliant to watch. Developers want to feed massive documents into an AI, but text tokens are extremely expensive.
Just to clarify for anyone new to the concept, a token is the basic building block of text for an AI.
Right, and models charge you based on your token usage. So these developers stopped feeding the AI raw text entirely.
Instead, they take screenshots of the text documents.
Exactly. They're feeding the AI pictures of text instead.
Because processing an image costs fundamentally less right now.
Yes. They let the AI's vision model read it back. It bypasses the text toll booth completely. We're literally hacking the economic constraints of the models. It's a perfect example of human adaptability.
Let's touch on some rapid-fire tool updates for you. These show how fast this landscape is actually moving. Meta is rolling out dynamic photo for Meta glasses.
It captures extra frames around a single taken photo. You can pick the absolute best shot much later.
That's a great consumer-level quality of life update. On the developer side, Longcat 2.0 is fully open source now. It was released under a highly permissive MIT license.
That's Meituan's 1.6 trillion parameter MOE model.
Let's define that acronym really quickly. And MOE is a model routing tasks to specialized mini-experts.
Instead of activating the whole brain, it activates sections. And Longcat 2.0 works perfectly with Claude Code and OpenClaw. Open testing for that massive system starts right now.
We also saw a major move in cybersecurity today. Cognizant and OpenAI launched a new cyber defense service.
It uses GPT 5.5 to validate fixes and speed remediation. The goal is radically strengthening overall corporate cyber resilience.
It shows how enterprises are trusting AI with critical infrastructure. But trusting the AI requires constant vigilant verification.
Definitely.
Which brings up a great piece of practical advice. A recent Claude thread recommends asking 2 specific audit questions. You should use them to catch weak assumptions and responses.
They also expose incomplete logical framing by the model. The advice is to end every single AI session with them.
2-sec silence. I still wrestle with prompt drift myself.
Oh, it happens to everyone who uses these tools heavily.
Prompt drift is losing your original context in long chats. You start asking about coding, and suddenly you're discussing philosophy. The model just loses the thread of what you actually wanted. These audit questions are a fantastic way to reset.
They force you to question the model's hidden blind spots. You explicitly ask the AI what it might be missing. It's a necessary friction in a fast-moving digital world. We have to maintain our critical thinking skills.
So, looking at Samsung's culture and the educational divide, will human culture fracture entirely before AI finally stabilizes?
Yes. Economic divides will likely deepen before the technology becomes fully commoditized.
The wealth gap widens before AI becomes cheap everywhere.
This is a placeholder for the mid-roll sponsor read.
Welcome back to the Deep Dive. We've discussed human hacks and complex societal friction. We explored how people are adapting to AI limits. Now we dive into the underlying hardware layer itself, because the hardware is attempting to eliminate those limits entirely.
It's giving us truly unprecedented processing speed.
NVIDIA just introduced a new block-based generation method. It's called the Nemotron Labs 2-tower architecture.
This thing is an absolute monster of hardware engineering. It fundamentally changes how an AI generates a response. Normally, models calculate one single word at a time. This new method generates text 2.42 times faster without retraining.
And it maintains 98.7% of the original model's accuracy. Maintaining that high accuracy without retraining is incredible. Usually, making a model faster means making it dumber.
Exactly. You usually have to compress it or cut corners.
Right.
But the hardware requirements for this are absolutely massive. It requires two 80 GB H100 or A100 GPUs.
Those are enterprise-grade chips that cost an absolute fortune.
Yeah, and it uses about 59 gigabytes of memory per GPU, so this isn't running on your laptop anytime soon.
Let's break down the methodology behind this speed increase. How does Nematron actually achieve this massive performance leap?
It essentially splits an existing 30 billion parameter model in half. It creates two entirely separate processing towers for data.
The first one is called the context tower.
Right, and this context tower remains completely frozen. It does not generate any new words at all. It just reads your prompt and holds the conversation history. It provides all the necessary context for the generation phase.
So it acts like a dedicated memory bank for the system.
Exactly. Then you have the heavily utilized mask tower.
This second tower does all of the heavy lifting. Normally, a standard model asks for the very next token. It predicts one piece of a word, then the next.
But this mask tower asks a completely different question. It asks, can I fill these 16 missing token slots at once?
2-sec silence. Whoa! Imagine scaling to 1 billion queries. It's like stacking Lego blocks of data, but doing 16 at once instead of one by one.
That Lego analogy perfectly captures the sheer efficiency here. It's predicting an entire phrase in a single breath. If the mask tower's confidence is high, those 16 tokens are locked.
But what happens if the AI isn't entirely sure? What if the phrase is complex or highly technical?
If confidence is low, the tokens stay masked. The system then refines the guess through a quick loop. It refines the guess until it's absolutely certain. Only then does it output the block of text.
This explains why it requires such incredible hardware overhead. You need massive memory to hold those parallel guesses.
Exactly. Those 80 gigabyte GPUs are working overtime to process this. But latency is the ultimate enemy of modern AI agents.
Latency being the delay before the AI actually answers.
Right. If you have an AI agent browsing the web for you, it can't wait. It needs to read, decide, and act in milliseconds. Reusing a pre-trained backbone makes this two-tower method incredibly valuable. You don't have to train a model from scratch.
You just change how it outputs the final text.
Exactly. It's perfect for high-volume inference and long-form content generation.
It sounds like a total paradigm shift for hardware. Will this two-tower method make single-token generation completely obsolete?
Eventually, yes. Parallel generation will become the standard for all major commercial models.
Single-token generation is definitely on its way out. Beat. Let's synthesize everything we explored in this deep dive. The main through line here today is becoming incredibly clear, whether we're looking at software, society, or hardware. Meta is running covert psychological tests on competitor models.
They're probing safety limits in the dark.
We see widening corporate and educational wealth gaps everywhere. The people who control the tools are pulling rapidly ahead. Meanwhile, NVIDIA is ripping apart models to make them faster.
They're restructuring the architecture to eliminate human weighting entirely.
The pursuit of AI supremacy is messy and highly expensive. Most importantly, it's largely invisible to the end user. We just see the magical text appear on our screens. We rarely see the human cost or the hardware sweat.
The next time an AI refuses to answer your prompt perfectly or seems a bit too fast, ask yourself something. Whose invisible guardrails are you bumping into? And what unseen architecture just built that response?
That is a phenomenal thought to leave on. Thank you for taking time to explore this landscape with us. Understanding these hidden layers makes you truly well-informed. It's the best shortcut to navigating the future ahead. Take care of yourselves out there. We'll see you next time.